So today's lesson is about ratios on the coordinate plane. I can apply my understanding of ratio tables so that I can create ordered pairs and graph the ordered pairs in a coordinate plane. I will know I've got it when I score 100% on the assignment following this lesson. So we had a little preview in our last lesson about how to create the equations for these ratio relationships. And we made tables, and we did do a little preview on how to use those tables to generate a graph or a visual picture of the relationship as an equation, as a table, and now the picture is as a graph. So we're going to read the scenario here, and we need to fill in the verbal description, the equation, and the table. And how we're going to do that is we're going to use the visual picture, the coordinate plane graph of this relationship to find these three pieces. Use the given information to fill in the missing representation. Margot is traveling on a family vacation across the country. That's all they're giving us there. We have to come down to the graph and figure out how to interpret the graph. So looking at this graph, I see that I have miles traveled. I'm going to label that. I like to label with letters. I'm going to call that M, and then time it takes to go that distance in hours. So I'm going to label that with the letter H. So the relationship is saying, hey, if I know how many hours I'm traveling, I can figure out how many miles I've got in that time. The distance, time compared to distance is what this graph is showing. So when you're looking at the graph starts on 0, 0. When you travel for 0 hours, you get 0 miles. So we're just going to fill in our table using the ordered pairs we can see right off the graph. And then the next piece that I see is if I travel for 1 hour, I get 50 miles. We can go to the graph and fill that in. If I travel for 2 hours, I have gotten a distance of 100 miles. 3 hours, 150. 4 hours, 200 miles. Then 250, then 300, then 350, then 400. So we can fill this table out pretty quickly just looking at those values on our ordered pair. H is your horizontal and M, miles, is your vertical. We're going to go 100, 150. They're giving us these numbers right in order, which makes seeing the pattern pretty easy. They didn't bounce around on us. So we've got our values filled out in the table. I'm going to fix that 3 because it's hard to see what that is. We got all our values filled out in the table, and those were the ordered pairs. 0, 0, 150, 2, 100, 3, 150, so on and so forth. So again, that key value that we're looking for to help us with this relationship is that unit rate, and it's right here. It says every time I go over 1 hour, I'm going to go up a total of 50 miles. Every hour I drive, I'm getting a distance of 50 miles. So we can see if I've driven 50 miles, I've driven for an hour. If I've driven another 50 miles, it's been an hour. And it's this stair step that you can see. Every time I go 50 miles, I've gone 1 hour. So that's our stair step. Just to make another connection, change colors here. This is an equivalent fraction table. So when I set these up as fractions, 50 over 1, 100 over 2, 150 over 3, they all reduce to 50 to 1. So that's why we see this constant 50 to 1 pattern. But remember, we have 2 and 100. So we can actually go up to 100, but if we do that, we have to go across 2 hours. So it would be 100 to 2. So that's just a bigger stair step, but it's still equivalent 50 to 1, our unit rate. We just double the up value, so we double the across value, and so it's a bigger step. It's like taking 2 of these smaller steps. And I can do that by going up to 300. I can go all the way up to 300, but if I do that, I have to go across to the 6 hours. So I've gone up 50, 1, 2, 3, 4, 5, 6 times. So the scale factor was a 6 for that. 300 took 6 hours. That meant I went on average 50 miles each hour. So it's a big stair step, but it's an equivalent ratio still. All right, so that kind of covers interpreting the graph and looking for that stair step, that consistent stair step, but also understanding we have equivalent ratios. So we can take bigger steps. We just have to make sure that we go up, how many times we go up compared to that 50 to 1, also is the number of times we go across compared to that 50 to 1. That's your scale factor. For example, this one was 2. And then this one right here was 6. And it will work for any of those. All right, so trying to come up with the verbal description. Margot is traveling on a family vacation across the country. Use the given information to fill out the missing representations. So our verbal description is saying, hey, how can you describe what's happening in this graph, in this ratio? So the verbal description would be, Margot is going 50 miles for every 1 hour she drives. It's your unit rate, and you're just putting the units on those numbers to see what it is. In this case, it's 50 miles to every hour. It's your stair step. It's your unit rate. Okay, the next thing we're going to do is fill out our table with the process we're using. So we know that if she drives 50 miles per hour. So we have the 50 is our multiplier. That's our unit rate. And we're going to multiply that by 0, and we get 0 over here. If she drives for 1 hour, we know it's 50 times 1. She gets 50 miles. If she drives for 2 hours, according to the graph, she got 100 miles. Well, that's 50 miles times 2. And then we just simply continue the pattern. 50 times what our number of hours generates our miles. That would be 50 times 4, 50 times 5, 50 times 6, and they went in order, so we're just skippy counting by 50 on our second column here. Every time I go up a mile, I go up 50, or up an hour, I go up 50 miles. That ratio, 50 to 1. Okay, so if we're trying to figure out the equation, look at the pattern in this table. Look at your process. Right here is your unit rate. That's in the entire formula. It's 50 every time. What's varying or changing is this value right here, which is how many hours you're going. So that becomes the variable H. They didn't give me the variable, but I chose H because I think it helps me to keep things straight. I'm taking 50 times the hours, and that's going to get me the miles I'm driving. So that is your equation. It's how you use the process to create the equation. So we're going to enter that right here. To get the number of miles, the miles is 50 times the number of hours. And that's the way the ratio relates as an equation. This is what the ratio looks like as a graph, 50 to 1. And this is what it looks like as a table. And to describe it, you just use the unit rate. Margot is going 50 miles for every 1 hour she drives, and you're all set. So now we're supposed to use this information that we entered into our missing pieces here to figure out the answers to these prompts. So we're going to start with the first prompt. What is the ratio of the number of hours to the number of miles? So remember when we were looking at this table, we were comparing the miles traveled to how long it took. So we did miles first to hours second. But this is asking for the ratio of hours to miles. So we're going to actually want to flip that ratio over because they're asking us for a certain order. So it's going to be hours to miles. So the ratio for that was every hour we went 50 miles. 1 hour of time got us a distance of 50 miles. So just following the order that they gave it to me, that's what I'm writing for my ratio. Okay, now looking at your graph, here's the 50 to 1 right here, or 1 to 50 in this case. So 1 hour, 50 miles. So we can get it right here off our unit rate on our graph. We can also get that ratio right here. 1 hour took 50, or 1 hour of time, you went 50 miles. So 2 good places to get that ratio. And then the next thing is how many hours will it take to travel 300 miles? Again, if you look at your graph, you can say, okay, 300 miles is right here. How long did that take? 6 hours. So for 300 miles, we took 6 hours to get there. So the answer here would be 6 hours. That's where we can find it just from the graph without have done anything else to this problem. But we did fill out a table and we did get the value right here. We got it as from the graph, 6 and 300, but we also got it using the process. The unit rate, 50 times hours 6 gives us 300. And that's right here. 50 times 6 gives us 300. So we could have generated it from the graph or the equation using that multiplication process. If this continues with the same ratio, how many miles would we travel in 15 hours? So we're looking over here at the chart, we're looking at the graph, we're looking at the equation. Well, 15 hours isn't going to show up on our graph. We ran out of room. We stopped at 10 hours. We stopped at 7 for the chart, reading it from the graph. But we do have this equation that says, hey, anytime you want to know how far you go, just plug in how many hours you're driving for and multiply it by 50. So we could continue this table using the process, using the equation. So it'd be 50 miles per hour times 15, and that will get us our distance. So you have to be savvy and really understand the different ways we're representing these ratios, and when it's easiest to use the graph or the table we're given, or simply the equation. So how many miles? It would be 750 miles traveled in 15 hours. If we were graphing that, it would look like this: 50 ordered pair, 15, 750. So in our chart, it would be 15 hours, 750 miles. Okay, the next question asks, what does the ordered pair 9, 450 represent in this situation? So you got to think, 9 is what? 9 is the horizontal, the first number in our chart, that's hours. 450 is the second number in our ordered pair, it's the vertical, that's miles. So what you find out there is that the ordered pair represents that Margot traveled 450 miles after 9 hours. So it's an equivalent ratio for 50 to 1, but she drove 9 hours, scale factor of 9. 50 times 9 is 450, and 9 times 1 hour is 9 hours. So we're creating these equivalent fractions. The next scenario, if you were given the verbal description instead, explain how you would graph the situation. So the verbal description would be like this. Margot traveled 50 miles each hour. That would be the unit rate, and that's what we use to help our verbal description, a ratio from our scenario. And the unit rate's always a good one. So if we got that verbal description and you had to graph it, you would just come over to the graph and you would start on 0 miles, 0 hours, and you would just go up. Every time you went up 50 and across 1 hour, you would plot a point. And then you would go up another 50 and across another hour and plot a point. So you're basically using 50 to 1 as your stair step for your graph. Up 50 over 1, up 50 over 1. So to explain that situation on how you would graph it using your verbal description. So again, we're going to create a graph from the verbal description. Would start on the origin, 0, 0, and every time you went up 50 miles and over 1 hour, you plot a point. So up 50 over 1, up 50 more over 1, plot a point, up 50, plot a point at over 1, up 50 over 1. So every time you go up 50 miles and write 1 hour, you would plot a point, creating this straight line pattern. And then at the end of our line, we would put an arrow to say there are more to this. It just keeps running up to infinity. So that would give you your graph. Just from the verbal description, we could create this graph very easily using that unit rate 50 to 1. Okay, so here we're given a ratio 7 to 5. And it says complete the table below and graph the values and then answer the following questions. So we're using a 7 to 5 ratio, X and then Y. X is first, Y is second in my table, so I'm going to put the 7 here and the 5 here. And since it's a ratio table, I'm just going to create equivalent ratios for 7 to 5. You can pick whatever numbers you want. I'm just going to try to keep it as simple as possible. I'm going to start with doubling both. So if I double 7, I get 14. If I double 5, I get 10. Then I'm going to come back to my 7 to 5, and I'm going to do that scale factor of 3. Instead of 2, I'm going to now triple. 7 times 3, 21. 15 times 3 is 15. Now I'm just going to go, I doubled, now I've tripled, now I'm going to multiply by 4. 7 times 4 is 28. 7 times 5 is 20. That's my scale factor. Now I'm going to use a scale factor of 5. 7 times 5 is 35, and 5 times 5 is 25. So every time I skippy count up by 7 here, I'm skippy counting by 5 here. So it's a 7 to 5 pattern. I went up 7, I went up 5. So now I'm at 14. I go up another 7, I'm going up another 5. Then up another 7, up another, right 7, up 5. Right 7, up 5. Saying it all backwards. Let me start over. We go right 7, up 5. Right 7, up 5. I might have said that all right. Right 7, up 5. Right 7, up 5. There's your stair step. This is your ratio. Using the information above, set up and solve a proportion. To determine the value of y when x is 49. What is the scale factor or multiplier? Okay, well, before we do that, let's set up our graph. So we're counting our ratio 7 to 5. Looking at our numbers, we have to be careful here because we've given a grid and it's set to how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes 10 tick marks this way and 10 tick marks this way. So looking at this, if I count by ones, I'm not going to be able to fit most of this table on the graph. So I need to adjust. So I can count by 2s possibly. If I count by 2s, am I going to fit? No, because it'll only go up 20 and 20. So I'm going to look at my x. There is a pattern here counting by 7s. So I think that's what I'm going to use because that'll be easy to graph these numbers if I just use 7. So 7 is my scale for my x. So I'm going to go x is here. It's the horizontal. See how our table is tipped over. It's not written vertically. the first is your horizontal and the second row is your vertical. So that doesn't change. So I'm just going to number 7, 14 neatly, 21, 28, 35, 42, 49, 56, multiples of 7, 63, and 70. So I got out to 70. I really didn't need 70, but that's all right. It's going to give me a good picture. I'm going to fix 63 because I can't read that. 63. You got to work neatly, write small so that you can identify that it's each of these lines are where those numbers represent. And on this one, I have to get up to 25. Well, I can easily do that counting by fives. And if you look, that's what we're jumping by here. Skippy counting by fives. So if you can figure out the Skippy count number, that's a lot of times that's a good interval to use. So the Skippy count on top was 7. And then our Skippy count for our Y was 5. So I'm just going to number all the way up. Don't really need them all according to my data. I just need to get up to 25, but I'm going to number all of them anyway, just so I'm showing a complete picture. And again, try to number it neat and try to line up. Whoops, that should be 50. Try to line up your numbers with the tick mark that they represent. Because if you don't, then your graph is not easy to read and we're not going to consider it accurate. Remember, this is 0, 0 right there, the origin. And again, notice we're only using one quadrant. They're just saying, hey, we're only interested right now in the positive values when they set it up that way. Okay, so let's plot the graph. I'm going to get my circle tool out and we'll plot some points for this graph. I'm going to start with 7 and 5 right here. Whoops, fill on that. 7 and 5, and then our next one is 14 and 10. So you can see by using that ratio 7 to 5, 7 on the X, 5 on the Y, we are very easy to graph because we're just literally going up here by 7 and 5 and falling right on these ticks. These two T's, we don't have to estimate our values. So we have a graph of the table up through 35. So 7 to 5, 14 to 10, 21 to 15, 28 to 20, and 35 to 25. So we're all graphed for our X and our Y. Now it says, hey, using the information above, set up and solve a proportion to find Y when X is 49. And then what is the scale factor? So we have our graph, and I am going to look right here. 49 is here. And it's saying, hey, figure out the solution for Y. Well, it's right here. Because when these two meet, they meet right there. So I'm going to use my graph as well as a proportion, which is what they're asking me to set up. So to set up the proportion, we're simply going to say, hey, we start off as X to Y. Remember the label. I like you to label to keep your numbers straight. And X was 7 to 5 for Y. A proportion is two equivalent fractions. Well, they say here that determine the value for Y when X is 49. So we're going to stick 49 in the top. So we're scaling 7 up to 49. And we want to say, if we do that, what does your Y value have to be? Because you got to scale it up as well. So we multiply 7 times 7. We multiply 5 times 7. And we end up at 35. So looking at this, that's what we got when we looked at the graph as well. 49 to 35, X to Y. Now the scale factor is right. How many times did we scale up the original ratio? We scaled each number up 7 times. So to get from this point, oops, I want to take it with me. To get from this point Change colors so we can see better what's happening. From this point up and over, we had to go over 49 and up 35. So our ratio is X over Y. So you can see that big stair step, and that's equivalent to going 1 time, 2 times, whoops, I should start here, 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, and 7 times. 7 steps to get from 0, 0 to this point. So the scale factor is 7. Lots of different ways to view it. Cool how it all fits together like a puzzle. Okay, we have 2 more problems to cover here. This one says, in 7 and 8, use your knowledge of ratios to answer the questions below. The 7 says, the relationship between the number of hours traveled and the number of miles traveled on a family road trip is graphed below. Question A says, what is the ratio of hours to miles? So we're going to use the graph to figure this out. Hours to miles. So I'm just going to use my code M to H. When I look at hours, in 1 hour, they traveled 50 miles. In 1 hour, they traveled 50 miles. So it's 1 hour to 50 miles. That's how we would express it as a fraction. 1 hour to 50 miles with the colon. And then in word form, it would be 50 miles per hour. 3 ways to express it. How many miles could the family travel in a period of 12 hours? Well, look at the graph. It only goes up to 10. So we might have to make some predictions here. If we were at 10, we would be at 500. So if I were to continue my graph, I would have to go up over 2 more hours, which would put me up another 100 miles. So I would be at 12, because that would be 2 hours. I get to 11, another 50, 12, another 50. So at 12 hours, I would be another 100 miles along. I'd be at 600. So you can kind of use the graph if you wanted to make your prediction. But another way you could do it is you could say, hey, if 1 hour is 50, 12 hours, that's multiplying that by 12. And if you multiply 50 by 12, you'll get 600. Equivalent ratios. So you'd use this 50 to 1 and you'd scale it up 12 times bigger because we want 12 hours. So we go from here up to 600 for 12 hours across. And if you reduce that fraction, it's 1 to 50. So it makes sense. So it would be 600 miles. Okay, how many hours will it take the family to travel 700 miles? Well, when you look on the graph, 700 is not on your graph. So we could say 1 to 50. And we want to know for 700. Well, miles, again, was coded to go on the bottom. Hours over miles. And we're trying to find out how long that's going to take. Well, how do you scale a 50 up to 700? Well, 50 goes into 700 a total of 14 times. So you would just multiply 50 times 14. And if you scale the bottom by 14, you have to scale the top by 14 to keep the fractions equivalent. So it would take 14 hours to travel that 700 miles. And if you think about your graph, we were at 12,600. If we go up to 14, we're going to go up another 100 miles. Every time I go up by 50 for each hour. So then 2 hours difference from here to here would mean another 100 miles. So that should make sense. Okay, this next problem says the relationship between the number of bread loaves and the cost of those loaves is shown in the ratio table. graph the ratios, and then answer the questions. We're going to do a graph of the ratios first. Well, our horizontal is the loaves of bread because it's the first row of our table, and then below it is the cost, so that's your vertical. And we're going to start at 2, 5. So we go 2 to 5. We have to estimate where 5 is going to land on this graph because this is counting by 3s, this is counting by 1s. I go right 2 and up 5. It's going to be just below that 6. And then my next one is 4 to 10. Again, 10 is not on the mark. It's going to be just above the 9. And then we have 6 to 15. 15 is going to be on the mark. These are multiples of 3. So 6 works because we're counting by 1s, and then we just go up to the T where 15 works. And these should be falling in a linear pattern, and they are, straight line. And then finally, 8 loaves of bread to 20. Well, 8 is here, and 20 is not going to be on the mark. It's just going to be below 21 because we're counting by 3s. 20 is not a multiple of 3, so we got to estimate where that's going to be. And now I'm going to connect those. If I do not have any loaves of bread, then we do not charge people. No, woo, that's a circle. Back on. The line tool out. And I'm going to start on 0, 0 because it makes sense. 0 bread, $0. And I only need the first quadrant on my graph. So I don't need any negatives. So I just start on 0, 0 and proceed upward from there. How much will 12 loaves of bread cost? Well, our graph doesn't go up to 12, but we can use it to kind of make a prediction. We know that the ratio of cost and loaves of bread is 2 for the bread. I'll put B for bread. L for loaves will probably make more sense. L for loaves and C for cost. And our cost is 2 to 5. We're going to do that. Trying to write in a little space here. L for loaves and C for cost. And it's 2 loaves cost $5. And we're trying to figure out how much 12 loaves is going to cost. So we set up that equal fraction. Okay, and then we'll use the graph to see if our answer makes sense. 2 to scale up to a 12 is times 6. So we got to scale the 5 by 6 as well. And we get 30. So we would expect that if you purchase 12 loaves of bread, you're going to owe $30. Because every time you buy 2, you spend 5. Okay, so we're looking at the graph and we are just estimating, here's our 30, and I'm estimating where 12 would fall. And it looks like it's going to hit in line with that. So it does make sense that when we are spending $30, we're purchasing 12 loaves of bread. The next one says if Annie has, let me erase that because I can't see it, $47.50. How many loaves of bread can she buy? So we are going to use that ratio again, loaves to cost, to figure this piece out. So loaves to cost, which was 2 to 5. That was the pattern they gave us, so we're going to stick with that. But we want to upscale that. We don't know how many loaves, but they said, hey, she's got $47.50 to spend on all this bread. So how do we get from $5 to $47.50? What's the upscale on that? Well, you can take your calculator and divide 5 into $47.50 if you want. What you'll find it's $9 or 9.5. It's 9.5 times bigger. So our cost went from a 5 to 9.5 times bigger, $47.50. So that means we're going to multiply this by 9.5. We're going to scale up how many loaves, 9.5 times more. And what we get is 19. We get 19 for that. So she can buy 19 loaves if she has $47.50. Not sure why she needs 19 loaves. Maybe she works at a sandwich shop. Buy 19 loaves to make her sandwiches. So that is the total number of loaves she can get for $47.50 when we charge $5 for every 2 loaves. And it makes sense, 19 needs to be smaller than the cost because we had 2 loaves to 5. So the number of loaves is always going to be less than the cost. So always make sure your number makes sense when you're done. And looking at the graph, if we were to go out way out 19, we'd be way up here at 47.50, hitting in line with this line right here. So today, hopefully you're piecing together the different ways we represent proportions, equivalent ratios or proportions as an equation, as equivalent ratios, as a graph, and with tables. And just pulling all that information together to help understand these equivalent ratio relationships. That concludes the notes, so hopefully you are ready now to go work on your assignment following this lesson. Good luck.